Hello again. So let's continue my journey learning SIG. And yesterday we looked at, I think we ended up at integers. So let's continue from there. Integer widening, I think that we went through that one, right? Let's see. Yeah, I think we did. We can just, we can store integers of a smaller size in integers of a bigger size without losing any information. So that is just possible. And if we want to make sure we are casting something or force something to be put into a smaller sized integer, then we will have some issues. I think that was what we tested yesterday. Yeah, we did this one. So we are not able to actually cast 2000 into an U8 as it's too small, so it can't contain it. So we will actually get an error because we are discarding information. But if we make sure that it's in that range by looking only at the reminder, then it can be done. I'm not sure, but I'm pretty sure that in C# you can just cast whatever to whatever, and it just discards the information as that is what you are asking for. I don't know if there's any way to just force it in SIG. But that might be a design choice. Why would you ever? If you need to do that, you have to make the decision again and force it into that data range to be, so you are handling how it should be done. Give me a second here. Sorry about that. There's a lot of stuff going around. And people are sick all over. And I have a tiny bit, I think. Or it's just that it's early in the morning. Who knows? When the body is old. Explicit conversion. Yes, we looked at that. Integers by default are not allowed to overflow. Overflows are detectable illegal behavior. I think we read that yesterday, but we didn't test anything. I think we copy pasted it. Yeah, well-defined overflow. So if we have an integer, then it can maximum be 127. If we add 1, it should be 128, but it can't. There's no room for it. So this should fail, right? Yeah, okay. The example says it goes to 0, so it just wraps around. Unsigned 255. Signed. Oh yeah, that was the last thing we did, and we couldn't make it work. So maybe if we go from 127, we add 1, it should wrap around. But that would result in this, wouldn't it? No. Test and modify and try it minus 27. It would be nice to see what the A value is actually containing. But we had issue. Can we use the just standard standard C out? Right, we can, right? It's just I want to be able to see some debug information when I'm running tests. But yesterday it looked like that wasn't possible. Let's see, A, and just ignore the try. It is minus 128. Okay. I knew that it wasn't symmetrical, but I couldn't remember in which side. So that just says that you are adding 1, but as you are adding 1, you go from the, oh, you can see the binary values right there. So you can see that, that should be 7 ones, but that's gonna be very hard. 1, 2, 3, 4, 5, 6, 7. Yeah, 7 ones. And if we go down here, you'll see that it's a 1 and 7 zeros. So it does just add to it that binary represent minus 128. That doesn't really matter. This just says add 1 in binary and just adds the 1. We are saying that we are okay with it just overflowing what this contains or how this is interpreted. We just add 1. So that makes good sense, and we can do this by plus minus multiplication. Plus equals minus equals and multiply equals. Fair enough. Floats. Let's move on to floats. 6 floats are strictly IEEE compliant unless set float mode .optimized is used, which is equivalent to GCC's -f fast math floats. So that's 2 different way of representing floats. So this is just normal floats, and again we can float widening. We can have this that has less precision in something that has better resolution and so forth. Float supports multiple kinds of literals. So we can initialize it by scientific notation, the normal way, so it doesn't add the f, which we sometimes see in, for instance, C#, where we differentiate the floats and the doubles. This would be a double unless we had the f for float. Yet another, why? Oh, okay, just see that you can use the capital E or just do lowercase e. And we have hexadecimal. Okay, I never seen that notation before. What is this p-5? p-5. That is just so weird. Hex floating point. What does the p5 stand for? Does it say anything? Okay, I need to Google that one because I've never seen that. What is this p-4? Sometimes I really hate search engines. When I say it needs to be on the page, it needs to be on the page, please. Doesn't seem to be something specific, so -5, -10 to the power of -10. Maybe it is. It's the power of something. Can we do this? And just add it. And just hover over it and see if it's being converted. It's not. Let's see. It's still the same. Okay. Do something simple as 1 to the not minus the power of, let's just say 2. And let's print out that value. I need to figure it out. Or I need to ensure that what I think is happening is actually happening. Huh. A quarter. So this to the power of -2, but it's in binary. So 0, 1, 2, 2, 4. See if we get halves here. We do get halves. Quarters, eighths. Yeah, 125. So this is binary, and it's kind of shifting the value. So what if we take, and it says 2? Yeah, 2 of these. Okay, that makes a bit of sense, but then what about this? If we say 0, then we should just get, yeah, again, it's in binary. So on this side we get 1, 2, 4, 8s, and here we get halves, quarters, eighths, 16th, and so on. Fair enough. Integers and floats may be converted using the built-in functions. Float from int and int from floats. Floats from ints are always safe. Yeah. It's always safe. That's kind of weird because when you do the integer conversions, where you have something that can't fit or you lose information, it's not allowed and gives an error. But here you can convert a float into an int and you will lose that information after all the decimals will be gone. Whereas is detectable illegal behavior, that's what it's called, detectable illegal behavior. Float from int, oh sorry, yeah. So float from int, where you will always have the information able to be in the float, but the other way around is a detectable illegal behavior if the float values cannot fit in the integer destination type. But does that include the decimals? Or is it just if the size is too big? But let's test it out. It says okay. So what are we doing? We are saying we have an integer that is 0, and we convert it to a float 32, float from int by a, yes, and we are then converting it back to an integer 32. And we can do this with any whole number, I guess. Yes, but what if we take b and says it's not a const, it's a value, a variable, and b plus minus plus equals 0.1. Now it's not a pure integer. It still works. So then I'm confused because now we are missing information. So if we take here and display B, and here display C. Let's just start with a new line here and rerun the test so we can clearly see this has this information, and when we convert it back to an integer, we discard anything in here. So what I think is talked about here, detectable illegal behavior, is if the B now is bigger than the size of what we are trying to convert it into. So again, if we are converting this number into an I8, which is way too little or too small to fit this information, as it only goes to 127, we should get an error. Yes, and we do. But what is the error here? Integer part of floating point value is out of bounds. Yes. Let's just run it again. Yes. So it doesn't detect it as illegal behavior if it has to discard the fractional part. It only detects it as illegal behavior if it's too large. I know I'm repeating myself a lot, but that's kind of the point. That's how it kind of stays in my head after the fact. Labeled blocks or scopes. Blocks in SIG are expressions and can be given labels, which are used to yield values. Here we're using a label called BLK. Block yields value, meaning that it can be used in the place of a value. That's weird. The value of an empty block is the value of the type void. So here we set count equal to the block that is defined by this. Try expect count to be 45. How? Oh, sorry. Sum 32 while I is less than 10, I plus plus. So this just adds up, but break block with sum. So it's not return block value sum. You can see this can be seen as being equivalent to C's I plus plus. Yeah, okay. A bit cumbersome, but yeah, I get it. That's, it feels like inline anonymous functions or something, that you can just add a block and have it return something. Do this. Does it need to have this? Unused block label. And if I take okay, no, it's still unused block label. It's probably because we don't have this, but we could just return whatever we want. What about a return? Return breaks unreachable code, yes. But what is the difference between this? Again, we don't have the block. We can't do that. Use of undeclared identifier. No, it's not. What about this? Use of undeclared identifier. BLK. Okay. I'm just trying to break stuff here. Yep. Ha, break stuff. Do I say a lot? Maybe I do. Get used to it. Yes. Does make sense. Why you would do it? I think that most of all, just this kind of anonymous function or something. But yeah. Simple, understandable. Next. Labeled loops. Loops can be given labels allowing you to break and continue to outer loops. Thank you. That is so useful for some scenarios. Oh, what an example to give. What an example. It runs okay. Is this outer? It's a loop of integers from 1 to 8. We are not using it. We are not. And again, this one, oh, is that just the naming of the current value? Saying that we are not using it. And then for 1 to 5, not using it, we count this one up, and then we continue to outer. So outer integer, inner integer, but what is this then? I don't even know how to do a for loop. Jesus. Let's go back and look at it. What we iterate over and its name. Then what is this? Oh, it's the array initializer. We're just saying we don't know the size of the array. Again, having it multiple places, just outer integer, sorry, and inner integer. And I want to print out the information so I can see clearly in which order everything is being called. So vals, can I do this? How do we do that? Is that the way to do it? Whoa. Yes. Oh, maybe we should have some nice formatting here. It's a couple of values. So it adds to count. We are not even looking at count. We're only looking at the indices here. But we know that count would be 1, 2, 3, 4, 5, 6, 7. 1 to 7, right? We're just gonna add count. Why not? Count starts at 2. No. Oh, phew. Yeah. It's strange that whatever is outputting this line isn't finishing off with a new line. But we can do that. Nice and pretty. Yes. So the first time we hit it, count is already being increased by 1. And we are seeing the outer loop going 1. And then we exit continue to outer, which is 2. And then we make a new for loop and a new array. And that's always 1 because we never get to loop over this because we just continue to the outer loop. I like that we're using outer, not outer, that we use continue, because that's what takes this one, right? We don't have the ability to do a break here. Then we have this loop. This should kind of be the same, right? Exactly the same. But this will only jump to the outer loop of this one. Sorry, just give me a second so I can clear my throat. Yeah. Damn it. This works because we only have 2 loops. So if I break out of this loop. With this, it really doesn't matter how many loops or how deep we are in this. Inner loop. Yeah, just for the fun of it. See, so if I used break, I would break out into this one. But because I use continue, I can point to the outer loop. Here, so I can skip 2 levels. Oh, fair enough. So as you can see, none of these, this loop's just, it gets created, enters the next one, which creates another array. To separate them, I could do something like this starts at 1, this starts at 111, and this starts at 111, 11, just to make it clear that they are different. And it's only the first one that is ever seen, because from this point, I just jump all the way out to the outer loop. Of course, you wouldn't use it this way. You would set a condition, so something that when you found something in this list, you exit out to the outer one. So you could maybe list through clusters of objects, and as soon as you find what you're looking for, you just skip out of not only that cluster, but the other subclusters if you split the screen up in a binary search tree or something. Cool. Very nice. The solution in Kotlin is really ugly, where we label it kind of after the for loop definition. So something like here, you have this ampersand and a label. It's really ugly. I really don't like the notation. This is really clear, and maybe the keyword. Do I dare? No. No. Okay, fair enough. Maybe they had reinvented or allowed to have go-tos. I think go-to, yes, it can open a really big can of worms, but just having this continue with a label solves 99.999% of all the issues where you would have used a go-to. But at times it would just be nice to have, when this happens, go to the outer loop or continue, because this just continues this outer loop. So it would be nice to just be able to skip that as well. So we could have something like down here, skip it all. While, for, inline, or so you can only label while loops, for loops, inline, or a new block. But what if I do an empty block? Is that allowed? That's not allowed. Unused block label. Yeah, I don't know. But yeah, that's where I would use go to is if when I found this, right now, if I find something, I also need to do the same check out here to make sure that I also exit out of this one if I don't want to do any more of that search or whatever. So go to has its place. Nice. Loops as expressions. Like return break accepts a value. This can be used to yield a value from a loop. Loops in SIG also has an else branch, which is evaluated when the loop is not exiting with a break. Okay. Let's play with it. Let's play with it. And again, it seems like it doesn't see it as a test. But then we can just run. Oh. Of course I can't run this one. It's this one. Yes. It passed. Try. Range has number. Begin. Okay, so we're just trying to find a number between these two unsized. While I is less than end, increase the value if I equals the number, break and return true, else return false. Why would we have else? Why not just have return false? Oh, because it is a return value. Oh my god, it's like the ifs can return values, so can whiles. Okay, so it's a bit of shorthand. Here we can, instead of having a value, return value or something that you set in here before you break, and then return that value or set it to false, or start by setting it to false. Normally I would just set it something like this, false. Oh, did I just remove? Yes, I did. And then return the return value. Could be const. Oh, that's why. That makes sense. This is not even needed. This is what I would normally do. Yeah. Just return true when you find it, and return false if this is being exhausted. But it's good to know that you can use whiles to return values just as you can do with ifs. I still don't really like that we can return values from a loop or an if statement. It feels weird that a break is a return and an else is a return. Breakthrough. Break is a break. It shouldn't take a parameter, but guess that's just how they decided to do it. Optionals. Did we finish this? Yes. Optionals. Optionals use the syntax $T, and I use to store the data null or value of type T. Oh, okay. So it's just saying that this this value can be null. I think we're using the same thing in C# now. Found index, make an array of integers, loop through it. If v equals 10, found at index. Okay, so we start by setting it to null, because now it's nullable. And if we find it, we set it to the index, and it's not in the array, so it will be null. Nice and simple. That makes sense to my brain. So if we take this one, we will very fast make this fail just by saying nope. Because this should fail right now because usize shouldn't be nullable, right? Yeah. Unexpected type usize found, type of null. So we have to specifically say that usize is nullable, so we set it to null. Optional supports the orals expression. Orals or else expression which acts when the optional is null. This unwraps the optional to its child type. Oh, okay. So we have this nullable value, so we can make sure to convert that to some value, a specific value. So here we set a to null. We set a fallback value of the integer null or 0. Let's call it 0. And then we set b equals to a, which currently is null, but b doesn't support null. We don't have we haven't set a value, so actually we could just set it to a. I think the compiler would figure out that this is a nullable float, but it can set a fallback value if it's null. So right now it says I want to set b to a, but a is null, and as it's followed by an or else, we get the fallback value. So b would be 0, and b would be of type float 32. Let's run the code. Yes, that's okay. If we set the value of this to some random number, it would fail because it would compile, but the test would fail because this wouldn't be right, because now it does contain a value, so it would take the a value, or that's what I expect it to do. And it didn't. What? 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 See, something simple, and apparently there's some... Oh, as I said, the test would fail. It's again, it's not clear if it's a compile time error or it's a test failed error. I think that's just me not being used to looking at this, because all it says is just that the test failed. And of course it fails. We have to update the test itself and say it actually returned that value instead of the default value. Yes, and then it works. Okay. Dot question mark is the shorthand for or else unreachable. This is used for when you know that it's impossible for an optional value to be null, and use this to unwrap a null value. Is detectable illegal behavior. Again, it's kind of the same. Why can't I see this? When I copy it using this one, there's some hidden text that is being copied with it. A bit of annoying. Tiny bit. Or else unreachable. We make a nullable 32 floats, set it to 5. Set b to a, or else it's unreachable because we have set it to a value, so we know that this won't happen. And unreachable will be detected as, what is it they're calling it? Detectable illegal behavior. And then we can take c and set equal to a dot question mark. A or shouldn't happen. So these two should be the exact same thing. That's what they're saying, right? This is shorthand for this. If one thing is a shorthand for the other, then pick one and stick with it. Having these two different ways of doing things, I really hate that. That's one of the reasons why I hate PHP as much as I do, because doing simple stuff, there's 10 different commands that does exactly the same, and they're named differently. So I would pick one in this instant. I think that if we don't have a good shorthand for this one, and we only have it for this one, then I would stick with the more verbose version of both and never use this. And again, this to me is more readable. I can see what it's actually doing. This, I need to convert it in my mind to this to say, oh, this should fail if that value is null. Both if expressions and while loop supports taking optional values as conditions, allowing you to capture the inner non-null value. Here we use if optional payload capture. A and B are equivalent here. If B value captures the value of B in the case where B is not null. Yeah, let's look at the code. that was just too much. Too much information and logic for this early in the morning. If optional payload captured. Again, we set a nullable int 32 to 5. If A is not null, const value 32, value is set to A. But we just tested and said that, oh, okay, so we are doing the check before we actually use this. So here we are ensuring that we can do this because A will never be null. So we'll never enter this and convert this to something that is actually a null. Doing the same for B. And now we're using pointer to value. And we can do stuff to it. So B should be 6. Try except B the value B is for sure not null, and it should be 6. So that should also work. Yeah. If B, oh, I was pretty sure that you were not able to do this in SIG, as they said that we couldn't do an if on anything else but a boolean. That was one of the first lessons. So we would have to say not null or something, so it evaluates to a boolean. But maybe there's something with null, so we can actually check if it's null, it's false. I don't think we get to run it because now this fails, so it just says it's a failure. It just fails. But if I do this, yeah, I learned that I need to click this twice. If I only click it once, it's like it's not updating everything. And I think I messed something up, and I just need to click it once more for it to work. So this actually works. I don't think it's ever going inside that loop now. Let's just output something. Gonna steal this one. I don't think that we are gonna be in here. No. But if we have value, we get in there. That's kind of weird because, as I understood, this shouldn't be possible. So even if I say it's the 0 value, is it still going in there? It is. Okay, so we can rely on if to detect if an integer is 0 or a non-zero value. It doesn't evaluate to a true or false. If it contains anything, apparently it's true. And only if it's null will it evaluate to false. So, kind of weird. Kind of weird. So right now we are, again, the pointer values, or pointer thing is still new and weird. What did I need to set it to 5? Yeah. So if b, and then we could take the value that we put in here and point to it. It's kind of weird. And then we can manipulate it and yeah, check it. Moving on. And with while, not wilds, but while, numbers left, function eventually null sequence. It can return an unsigned integer 32 or null. If numbers left equals null, return null. Numbers left -1, so every time we call, oh, we have a global value. We have a global variable with numbers left, so we can just, that's being counted down, and it will return null at some point, and we can check that. While, oh, so while also are able to evaluate on the value. That's again different. Yes. Again, add some output so we can see what's happening. In a learning scenario, it's so important to know exactly what's going on. Some. 3, 5, 6, 6. 3, 5, 6. Oh, okay, yeah. We add the value. Sum starts out by being 0. So it's not actually the sum that is interesting. It's actually the value. Oh, oops. There it is. Whoop, there it is. Yeah, 3, 2, 1, 0. So let's just think about this for a second. So again, like in the previous one where we have if b, we can take the value that we gave it. The same is happening here. Here we're just giving it a function call, but the return value from that function we access here. We have that value, we print that out. So after the first call, we have 4, and it's being decreased by 1, so it returns 3. 3 is inputted here. and we add that to the sum 3. Output and continue until we get a null value. As soon as we get a null value, it stops. Is that by just adding this? Again, something is being obfuscated here. I would much rather like it being, while this is not null, instead of having this. Yeah, I know it's not hitting the right value. Of course it's not. But yeah, that to me is a lot more readable than doing this. But of course, if you already have the value, what if we say not equals to null? Is that, it shouldn't change anything, but it does. Expected optional type found bool. So you either have to do the one or the other. Yeah. I'm not sure about that one, how I feel about that one. But I read Who Moved My Cheese, so I just have to accept that that is the way they're doing it in SIG. And if I want to learn SIG, deal with it. So it's while, oh, am I being stupid again? I think so, because of course, while this is true, this is the evaluation, yes. And as soon as that returns false, or not false, but null, it will evaluate to a false value, and it will stop. It has nothing to do with this. This is just being able to have access to that value that has been returned. Okay. Makes sense. It's a learning experience, and that's why I really try to make clear this is not a tutorial for anybody to follow to learn SIG. This is my journey, and you are welcome to join me and have fun seeing me, stumble upon easy things like this where my brain just, glitches out. So that was this one. Optional pointers. Comp time. Blocks of code may be forcibly executed at compile time using the comp time keyword. In this example, the variables x and y are equivalent. Fibonacci numbers. Yes, this is a small function just to calculate the Fibonacci numbers. Comp time block, comp time Fibonacci. Oh, so it's setting a const based on the call to a function. Const comp time for this block break return this. Yeah, that's exactly the same as calling it this way. This is just called through a block that we learned just a few minutes ago, and both should be the same. There's nothing interesting in that. My question is, does this live after compile time? Because after compile time, these values have been evaluated and set, and this will never be called again. So that's something I would like to know, if that is being discarded before actually having the final executable. Integer literals of the type comp time int. These are special in a way that they have no size. They cannot be used at runtime. And they have arbitrary precision, comp time int values coerce to any integer type that can hold them. They also coerce to floats. Character literals are of this type. Arbitrary precision. Okay. We have a equals 12, b equals 12 plus 10, 22. We have an unsigned 4-bit value that tries to contain a. So we have 1, 2, 4, 8, so that's okay. D is a float, 32, that contains b, which is 22, that's also okay. Yeah, so arbitrary precision, is that because you can have these U4, U5, U6, or whatever? Comp floats are also available, which initially is an F128. These cannot be coerced to integers, even if they hold an integer value. Okay. Types in SIG are values of the type. Types in SIG are values of the type. Communication is hard, and especially in text. These are available at comp time. We have previously encountered them by checking the type of and comparing with other types, but we can do more. Okay. Oh, branching on types. That's a good thing to be able to do. I don't know if SIG has some generics built in, but time will tell. It's testing. Comp time int, that's 5. If a is less than 10, we put it in a float, 32, else an integer, 32, and set it to 5. So we can set a const value. Can we do this? Oh, it marks it as a comp time integer. But does that matter if I set it to, can I forcibly set it to an unsigned 8, for instance? Now it's not a comp time anymore, but it still works because it shouldn't make a difference. And if I set it to 15, it should fail. Yeah, again, I had to click it twice. To make it work. It's really weird. Yeah, because now it's above 10 and it should be an integer 32. And it is. Perfect. Makes sense. Let's see, we passed the 1 hour mark, so I will stop for today. And we will continue on this matrix. What is function parameters in SIG can be tagged as being comp time. Function parameters. Okay. Looking forward to that one. But yeah, let's look at that tomorrow or the day after. Whenever time allows, I will continue this journey. So for now, remember to check out the video on YouTube as well and comment to help me understand. That would be great. And see you next time. Bye.